Well, it's time for another the Astro 30's Electronics Lab video, but before we do that, let's have a look at the dog anus clock. So the long hand is pointing straight up to the 12, so it's something o'clock, and the short hand is pointing to the 8. So it's 8 o'clock on the dog anus clock. Greetings, the Astro 30 here, and today I don't really feel like doing an electronic-y video because I'm not feeling the best today for reasons best known to, well, nobody. We're going to look at the EX-5 5-string bass kit again because, well, I did some research on the internet and I believe these pickups are wired incorrectly because these are 4-conductor humbucker pickups, and all 4 wires really should be used, and I'm only using 2, well 3. Let's have a quick look at how these are supposed to work. Now, please excuse the crudity of this, but we can imagine the humbucker pickup is split into 2 separate halves here, one north and one south. Now they're called north and south because of the different composition of magnetic material used in the north compared to the south. Now if this was a non-sealed humbucker, you would see screws and slugs. These red dots indicate the slug side, which is always the north, and what look like screws on top of the pickup is the south, and always is. So what we want to know is where are north, south, ending wires and starting wires are respectively, because the way there's 4 ways to wire them. There's one wiring the 2 coils in series, there's one wiring them in parallel, but the one I'm interested in this instance is wiring them in series because that gives the maximum amount of gain plus the maximum amount of noise cancellation. So we need to work out where the north start is, the north end is, the south start is, and the south end is, or you can say south start, south finish. It makes no real difference. Normally what we would do in this instance to wire them in parallel, the north star is going to be the hot wire which goes out to the potentiometer. The south start, which is over here, is going to be, I'll change colours here, is going to be the ground. So that means the north end and the south end respectively have to be wired together, and then they don't actually connect to anywhere else. So that is what I'm going to be going with. So the next thing to do is to figure out which wire is which. So for all intents and purposes, we're going to assume the north is going to be on the neck side or the headstock side, and the south is going to be pointing towards the bridge. I'm going to mess around with this pickup first. I'm going to actually turn the volume pot of the bridge pickup down and the one on the neck pickup all the way up. Now first we're going to plug it into an amplifier and do a quick sound test to see what the actual level of gain without touching any volume controls here or on the amplifier, just to hear how much gain it has at the moment. Now I don't profess to be an expert on guitars at all, and there's probably people that are more, I don't know, privy to this sort of thing, screaming at the screen, I can't even talk right now, saying, "You're doing it wrong." Anyway, so that's the open B, and that's the open G, and we can immediately hear there is a difference between gain between, well, the lower strings here. A is not too bad, but D and G seem to be the loudest, and that could be for the reason that the pickup is only half wide and the other coil is not really doing anything except acting like an antenna, because one wire is joined to it, but the other end is just left floating, so it's acting like an antenna. So what I have to do is crack out the soldering iron, which is going to make extra noise into the amplifier. If I turn that down, it goes away. Unsolder the pickups from the pot. Well, the pickup from the pot. Unsolder, they've already pre-joined the shield wire to one of the other wires, which I think was the green wire. So I need to disconnect them, so I've got 4 conductors, and then we'll do a few little measurement tests to work out where things are. Yep, that's right, I forgot. I've actually got 4 conductors plus a shield. So the shield is always going to be ground, but that doesn't mean to say that that green wire is actually in the correct point, but that could actually be the end of the south coil. But the red and the white one here, which I don't know if you can see, are actually joined together, and this black one is left floating. So we'd have a ground, two ends of one coil and one end of the other coil. So now I need to work out which way round they are. So I need to first get rid of this piece of heat shrink and unsolder it from the pot and from the ground, and float the pickup out, and you'll see next what I'm going to do. Right, so I've got the first pickup disconnected from the pot. I've disconnected the red and white wires that were joined together when I actually received it. So first I've got a multimeter here set to the ohm scale. We've got to really identify which coil is which, or where each coil is with respect to the wiring. So I'm just going to come around the other side of the tripod. Now I'm going to touch these two together, preferably without my finger there, because that will give me a false reading. So that's not a coil. Neither is, oh wait a minute. Let me do something a little bit different here. Right, so to make my life a little bit easier, I've connected a jumper cable to one end so I don't have to hold it. Right, so the red and the white are not a coil. The red and the black are not a coil. However, the red and the green plus the shield gives me 6.5 kilo ohm. Okay, so I've written down red plus green is 6.5k. Now that leaves black and white, so that should be the other coil. So I'll just move that from the red wire to the white wire, and now put this across the black wire, and again we've got 6.5k, so both coils are the same. And so I've written down black plus white equals 6.5k. Now, how do we know which coil is which, like which side of the pickup is it on? So we'll go red and green, red and green, which is one coil, connected across the meter, and we'll go to the voltage scale now. Now we already know that the green wire with the shield around it is going to be the ground side of the coil, but what I'll do, okay, so we got 14 odd millivolt DC in the positive direction, so I know that the polarity of my meter is correct, so whichever lead the negative lead is connected to on that pickup, that is the end of the coil. So if this was a negative reading, that would be the positive lead would be the end of the coil. So we need to know where the two ends of the coil is. So I know the one with the shield on it is going to be ground, so that does technically mean that that's the south coil. So that's the green wire, we'll say, so we'll leave that alone. So the green is going to be the ground with the shield attached to it, which is going to be the south start. So the south end is the red wire. So we'll mark that as red. So just repeating the test with the other two wires. Looks like I'm getting a more negative voltage with the negative probe connected to the black wire. So that means the white wire, for all intents and purposes, should be the north end. So it's relatively simple. What they did at the factory was, let's just put this in for perspective. That's the white wire and that's the black wire. So what they did when they supplied the pickups is they wired both the red and the white together. So they should actually be joined. So the green and ground, or the green and the shield, is our ground, and the black should be the hot wire. So if I now leave these connected together but left floating, and then connect the black wire to the pot, let's see what happens. Alright, so for testing purposes I've just hooked the pickup directly to the lead. It's the same thing anyway. Apart from that buzz, let me turn the soldering iron off. Actually, for all intents and purposes, just turn that off, all strings sound like they've got a little bit more gain behind them now. So what I might do is I might solder that in properly now. So here's a closer look. I've got the two pickups wired the same, and I've got heat shrink sitting on the two joined connections, just so that they don't short on anything, because don't forget this is now earthed or grounded. So now we can plug this back into the amplifier. Turn it back over on its back. Now I've still got that one down. Now it sounds like all strings have more gain than they started with. That's the bridge pickup. And I'm no longer getting that other problem that I was having, which was when you had both of these controls rotated all the way up. That would bring the two pickups in parallel basically, and it was dropping the impedance down, so you would notice a significant loss in gain, but it doesn't seem to be doing that. Which means it's now wired as it's supposed to be. So I have fixed that. It's very hard to play with it on the desk. So let me just kill the soldering iron. There's a lot less noise now than there was when it was wired the other way, because I had I don't know, high-pitched buzz coming from somewhere. So what we can do now is I can put the back on for the final time. Remember not to over tighten these screws, or you will strip out the hole and have to stick something like a matchstick down it to unstrip it, which is always a pain in the ass. But There we go, that's all now back together. It doesn't need to be off anymore. Oop. Very little noise. That sounds a hell of a lot better than it did to start with. And just to compare it, I'll grab the other bass guitar and see if the levels are almost the same. Well, these are different pickups for a start. Right, so that's the level of that one. It's not as loud, no, but is it better than it was before? Most certainly yes. So this is a final look at our diagram that I've come up with. When the pickups were sold, the red and the white were joined together by default. So those are the two end coils. And that's basically all you're trying to work out is one, where each coil is, and where each end of the coil is, so that they're in phase. And you use the multimeter on the DC voltage range to do that, and wherever the black probe is, usually is where the start wire of that coil is. That is, however, if you're getting a positive voltage swing on the multimeter when tapping on the pickup with a metallic object such as a Allen key, as I was. If I was getting a negative voltage, that means wherever the positive probe was connected is the start wire. Now on this side I had the black probe here, and that was the green and the ground respectively. So that was the south start. The south end was obviously the red probe. Over here I had the probes reversed, so I was getting a negative voltage swing. So that meant where the negative wire was, which was over here, was now going to be the north end, which was the white wire. So the negative side of the coil, or the north start, was the black wire, which then became our hot wire, as these two are joined together. Now, using a multimeter, unless you've got a really expensive one with a good peak hold function, it may be hard to actually determine. You're going to have to sit there clicking on the pickup with the Allen key several times to get a valid reading. You could use a time capture oscilloscope or something to yield better results, but it's entirely up to you. But it's working out basically the polarity of these coils, because when you wire two coils in series and even in parallel, it also makes a big difference in parallel, because the second type of wiring is to wire it in parallel. But when you wire two coils in series, it's the same as a power transformer. If you wire one of the secondaries back to front, that is 180 degrees out of phase, then what essentially happens is, as the coil on one side energizes and the other one on the other side tries to energize in the reverse direction, the two voltages basically will then cancel each other out, therefore you'll end up with 0 volts out. And in the case of pickups, you'd end up with no output. So if you're mucking around with your wiring in your guitar and you wire two together and then have a hot and a ground, and then find you've got no output at all, you've wired the coils together 180 degrees out of phase with each other. And so basically just reverse one of the wires and try again. I mean, you've got 4 wires, you've got probably 4 opportunities to get it right. Basically it's just, trial and error, unless you really know what you're doing. Eventually you'll get it right, you'll get the most gain and you'll get the most noise reduction, which is the whole entire point. But that's how I went about doing it, and because they're both 6.5K, that means now we have a total impedance, not with both pickups connected together of course, we've got a total impedance of 13k. And when both pickups are put into parallel with each other, that drops it back down to the original 6.5k. Now, the way it was wired before, I had 6.5k output, and when I had both pickups going at the same time, I had 3.25k at the output, which was then going to give me a severe reduction in gain. And that's the reason why. So now with both pickups turned all the way up on their volume pots, we're getting 6.5k total impedance. If I wind one of them down, well, we're going to get 13k. But it doesn't seem to really affect the overall gain when you do that. So anyway, I hope this video was useful to someone. I've been meaning to get around to solving this issue of what that sodding black wire was for ages, and just never got round to it. But I have now, and the next stage would be, when the weather starts warming up, is to give this a nice coat of new varnish with a brush, paintbrush. I'm not going to pull it all apart to do it. I'll just mask off, take the strings off, mask off the bridge, the pickups, the pots, and the output jack, and the back plate as well, and round the hair, bottom of the headstock here, and just paint around it, and just go in continuous straight line strokes, smooth even strokes, and it should paint all right and come up a little less rough than it is now. So let's see what it sounds like. Sounds alright. Anyway, I'm the Astro30, and if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyway, this is the Astro30 saying, see ya, thanks for watching.